Okay, so greatest common factoring. All right, let's take a look at the first one. 21 and 14, and they're setting you up. It's like training wheels. How do you get to a factor where it's 3 and 2 when you're starting with 21 and 14? Like, what do you got to take out? What factor? The 7. Now, do you see how both of those terms, one term has x, one doesn't? You can't take an x out, right? Because it's not in common. You can only factor out what's in common, and in this case, it's only a factor of 7. So 7 goes here. It's 7 multiplied by the bracket 3x plus 2. Now just visualize going backwards. What if you multiplied 7 inside this bracket? Would you get what you started with? All right, that's this. Expanding and factoring as reverse processes. When the 7 goes in, that's called expanding. When the 7 comes out, that's called factoring. The next one's also sort of like training wheels. They've done it for you. Like 5 became 1, 15 became 3, 5 became 1. What do you have to divide by to make that happen? 5. Now think about the variables. A4 became A2, A3 became A1, and then A2 became A0. How many A's were removed? 2 of them. 2 factors of A. 2 factors of A is A times A, which is A squared. Make a note. I don't think the numbers is too much of an issue. When they're bigger, like you got to use a calculator and such, usually you get more realistic numbers. So the numbers I'm not too worried about for a high school student. It's the variables. Like A4, A3, A2, the minimum they have in common is A2. That's what needs to come out. Now the next one is also training wheels, but they're going the other way. Now they're taking out the factor. So 5a is factored out of each term. What does that even mean? Factored out. Let's just do a number. I'm going to factor out the number 10. I know 2 is a factor because it's even. 2 is a factor. If I factor out a 2, the other factor would be 5. I'm factoring it out. You're just listing factors. And what we want to do is choose the greatest common factor. Now for 5 and 25, what's the biggest factor that divides them? 5. For a squared and a, what's the biggest factor that divides them? A. Put them together. That combination is the GCF. 5a is the GCF. It needs to be factored out. What does it mean to factor out? It means you have to divide this in your mind. The first term, if you divided 5a out in your mind, what would happen to those 5s? Cancel out to 1, and then a2 and a1, that would leave you with just 1a. Good. Now move on. Divide this one by 5a. The a's would cancel, and 25 divided by 5 is 5. Next one's also done for you. So now I want you to just try to imagine it in your mind. 18x cubed divided by 9x. 18 divided by 9. And then how many variables were taken out? Only x1 was taken out. You started with x3. So now you have x squared. 45 divided by 9 is 5. Is it positive or negative 5? negative 5, and how many x's are left? And then the very last one, 9x divided by 9x. 1. Now visualize this. If I re-multiplied that, would I get this one? If I re-multiplied, would I get this one? And finally, the last one, if I re-multiplied, would I get this one there? So now no training wheels. I'll do the bottom 4. You guys can do the top 4. Bottom 4. Okay, 2, 4, and 6. What could I divide out of 2, 4, and 6? And here's a tip. Just check all the numbers. 2, 4, 6. Check the smallest one available. Like, does 2 divide 4? Does 2 divide 6? And of course, 2 divides itself. So that's a good way to look at it. It's going to be 2 for sure. Don't worry too much about the negatives yet. Now, what variables do they have in common? Do all of them have a? So I cannot choose a. Anthony, do they all have x? They all have x? What's the minimum? Oh, it's all the same. So I can take out 2x. Now, open up a bracket. You open up a bracket the size that would allow 3 of those terms to fit. Now you have to divide 2x out of all of those separately, one by one. What's the first one? Negative 1a squared. Do you see it? What's 2 divided by 2? 1. And x divided by x? 1. So you're just left with that negative a squared. Now divide 2 out of the next one. What do you get? 4 divided by 2 is 2. I'm not doing anything with the a's, and the x will cancel. And the last one? 6 divided by 2 is 3. Keep the sign. When you divide by positives, you keep the sign. Now I'll show you the negative. The same equation, the exact same equation, I'll rewrite it like this. Now what have I factored out? What factor did I factor out? How did I become from a positive 2x to a negative 2x? What factor came out? Negative 1. From this step to this step, I took out a negative 1. What's going to happen to all of these? Switch sign. My imagination, basically, because when you write polynomials, typically you like to have the very first term with the highest power. That's called the lead coefficient. You want this one to be positive. That's just a convention. I could put the negative 1 back in, if you'd like, and then I'd be back up here. I could put the 2x in, and then I'd be back up here. This stuff is going to take practice. For us, my generation, it was grade 9 we had to do this, and I'll still forget, like, there was many a nights where I was like fed up because I couldn't do it, but eventually I just got it. So please just keep at it. If you want to have success, you got to keep practicing. 4, 8, and 12. What all divides 4, 8, and 12? And a nice trick is to just look. Look at the smallest number available. The smallest number available is 4. So does 4 divide 8? Yeah. If 4 divides 12, yeah. And of course 4 will divide itself. What if 4 didn't divide one of these? Try a smaller one. Like look at the next one. 40, 20, 15. Try 15 first. Does 15 divide 20? No, so go smaller. Does 10 divide 20? Does 10 divide 40? Does 10 divide 15? Go smaller. This one's 5. Yeah. Okay, back to the middle one. Do they have a in common? What's the minimum a they all have? A to the 1. Do they have c in common? No. So that's the GCF. You write it off to the side, and then you open up a bracket that has enough size to fit those terms. I got to fit 3 terms in there. I got a spot for the first one, the second one, and the third one. There needs to be room there. Those 3 terms are going to be scaled down. They're scaled down by a factor. 4 divided by 4 becomes, this is 1a here. The next one is just 2, and the next one is a 3c. I just want you to scan this leftover factor. Is there anything in common? Is there anything in common between those guys? Can I divide anything else out of that? That must have meant 4a was my GCF. I did it properly. 4a is the GCF. Okay, last one by me. You guys will do the ones above. We already said that 5's the biggest number. And how many x's could I remove? Good. Now you open up a bracket with the size for 3 terms. 40 divided by 5, and 2 are coming out. Next one, 20 divided by 5. Remember the sign is negative. And how many x's are taken out? 2. So I just don't write anything. And then the last one, 15 divided by 5. Now that's done, and it's correct, but by convention, this looks really weird. It would look better if these 2 guys were switched. You want the square, the x, and then the constant in that order. That's just a convention. So you could just rewrite it. 8x squared plus 3x minus 4. Okay, you guys try the 4 above. All right, let's take a look at your solutions. That one's pretty straightforward, right? First one you can only take out a 6, right? How about the next one? What can you take out? And what goes with the 9? X, good. Then you'd be left with 5x minus. Very nice. Next one you can only take out, and you'd be left with x squared minus 2y. Good. Thank you. Now the last one, like, this is my tip. Check 10. Does 10 divide 25? So then it's got to be smaller than 10. 5a squared. Divide 5a squared out of both of those. 5a minus 2. We're going to be doing some much more advanced factoring for Math 10C. If you really struggle at it, your destination is probably Dash 2, where there's less of this factoring stuff. In Dash 2, at the 30 level, this is pretty much all you have to do for factoring. It's nice. And there's maybe one more thing that we'll show you that you have to do in 30-2. So we'll see as we go, especially next week when we get into the real, it's like real deal algebra. Hopefully you can sort of relate to it, and if you can't, you know, it is what it is. These next ones These next ones are a little bit different because the greatest common factor is a binomial. On the last slide, the greatest common factor was a monomial. Look at these expressions. They all have a very similar structure. In the first one, and this is very important, how many terms are there in the first question? Very good, whoever said that. There's only 2 terms. See, the first term separated by a plus on the other term. Now, for those 2 terms, what do they have in common? 7 and 2y. Nothing there. But they both have this binomial. The binomial is just an object. Okay? I have an S7. Who else has an S7? Okay, we have something in common. It's an S7. These guys have something in common. It's a binomial. You can factor that binomial out. Now you have to open up a bracket. Remember when you factored the thing off to the side? You have to open up a bracket. And you have to leave room. You have to leave room for whatever's going to fit there. How many terms did we start with? So how much room should we leave for? 2. If I divide the 3 minus 2y out of this one, what am I left with? Only the 7. Imagine picking this guy up and moving it off to the side. Same with this one. Pick that binomial up, move it off to the side. What would be left? The plus 2y. This one is right there, and this one is right there. Imagine they're like factored out. They're divided out. What's left is just those 2. Now these next 2 are special cases of this process. I'm just going to give you guys one more to practice before we move on. So just write this one down. Look at this expression. What do they have in common? Just the x plus 1. Factor x plus 1 out, which means divide it out. What would be left? A 5 and a 2y. Now these 2, they're just special cases that typically throw students off. That's why they're put up here. They're just special ones. In the first one, or the middle one here, they both have what in common? Yeah, the Samsung S7, right? They got the Samsung S7 in common, right? Pick it up, remove it. What would be left over? The first one's easy. If I pick up, remove 2a minus 1, the first one's easy. But what about that second one? What goes there? It's definitely 1. And which sign? Good. Because you have to think in terms of objects. Like, imagine 2a minus 1 is just my Samsung. How many Samsungs do I have? I got 4a of them. How many Samsungs does that guy have? He's only got -1 of them. So you think of them as objects. Now, the last one, I'm going to put a negative trick. And I'm going to zoom into it. So I have the Samsung S7, and Ifra has the Samsung S7 with a girly case on it. It's got purple and pink, little dangly chain on it. Right? Mine's just base. It's got the otter box because I drop it all the time. She has like glitter on hers, like jewels. So nice. Is it the same phone? Just looks different, right? Don't those two basically look the same? What's different though? Switch in terms of I'm a human being. I have lots of qualities. I'm a boy. I'm tall. I have black hair. You know, I'm decently thin. I'm not too thin. You know, I got white skin. Like, what else? What about me that makes me different than other people, right? What is it? I got lots of qualities. These polynomials, they have nothing special about them except for two things. They are either positive or negative. I mean, human beings, they can be defined by lots of different features. Polynomial terms, they got two options. That's not a really good life. So what option is this x? He is, or positive. What about this one? So they're the same thing except they differ by a sign. What about that? -3, what's this one? Pretty much the same thing, just opposite sign. So watch this trick where I put my pen. I just rewrite the first one because I'm not doing anything to that guy. Now watch this. What did I do? How do you make a negative become a positive with a factor? What do I multiply -4 by to get +4? What goes there? -1. So to switch a sign, all you have to do is multiply or divide by a negative. So if I times that by a negative, essentially the negative was removed from this. If the negative was removed from each one of those factors, what happens to the +3? Yeah, -3. And then this one becomes +x. Now they're the same. They're in the wrong order, but they're the same. Now you don't have to do this, but I'm going to, just to show it, not touching the first term, I'm just going to rewrite the order so it really is the same. Now what do they have in common? X minus 3. So you factor that x minus 3 out, and what's left over? 20x plus 4. And now this is where a lot of people, I don't know if you get mad or what, but it's not finished. And you go, oh, what? We just did so much. What do you notice about 20 and 4? Do they have a factor that's in common? Yeah, they do. So this is what makes life kind of hard for students sometimes. When I say this on a test or a quiz, if I say that, you have to be completely factored. Or if I say this, it has to be completely simplified. So this would get you like not even full marks. It's unreal, hey? Tough love. So what could I take out of that? A 4. What would be left? 5x plus 1. Very nice. And then I'm just going to rewrite it to make it look cuter. The coefficients typically go off to the left. Just a quick question on the side. 5 times 2 times 3. 5 times 2 is 10 times 3 is 30. Okay, 2 times 5 times 3. 2 times 5 is 10 times 3 is... Does it matter the order you multiply? So the fact that I moved that 4 to the front doesn't change the expression. It just looks prettier. And that's what we love, to look pretty. You guys feel okay about this? Now we move to the bottom here. This 4 terms, this is training wheels for what's about to come. If you were just given this, what would you probably do with the 3x and the 6x? Like, what would your instinct tell you from grade 9? What's 3x plus 6x? No. Okay, stop. Back to basics. What's 3 apples plus 6 apples? So what's 3x plus 6x? Just 9x. Right? What's 3 apples plus 6 apples? 9 apples. What's 3x plus 6x? 9x. What's 5q plus 5q? You're welcome. Remember that joke? Don't worry about the joke. The reason that this is not 9x is because there's something special about 3 and 6. I'm going to put it together, actually. Let's put it together. That's just collecting like terms. Do you agree? Now, this you're going to have to just leave in your mind right now as a mystery, and we will uncover it later. I just want to change 9x to 3 and 6 for some reason. Does anybody think, like, why don't I have 2x plus 7x? Why isn't it 1x plus 8x? Why isn't it 4x plus 5x? What's special about 3 and 6 in relation to this problem? What's the 18? What's the product of 3 and 6? Oh, something special going on there. Look at these two. What would your like terms tell you about that one? What's minus 2 plus 12? Positive 10? Okay. For this one, what's 3 times 6? 18. For this one, what's 2 times 12? And look at this. What's 3 times 8? Weird. Look at this one. What's 4 times 10? What's 8 times 5? So it's done on purpose. We're going to be doing like algebra diagrams later, like this. And what they make are these rectangles with like special things in each. Okay? And the only way to make these rectangles is if they add up and multiply in a really nice way here. We're going to talk about that when the time comes. Right now, you just got to take it for granted. We're just going to be working on our skill, our factoring skills, so that we can build to the point where we can understand what's coming. So, and again, this is going to be a bit of a mystery for now, but you want to put them into pairs. And you want to grab a GCF from the pair. So for the first two, like, what do they have in common? X, right? So factor x out. What are you left with? X plus 3, good. What about the second pair? What do they have in common? What divides 6 and 18? What's the tip? Always check the first one. Does 6 divide 18? So that's the one. That's good. So I can take out a positive 6. If I take out a positive 6, what am I left with? X plus 3. Oh, wait a sec. Now it's like that problem from the top of the page. What do these x plus 3, when they factor out, what's left over? Yeah. So this expression here and this expression here are equivalent. This one is a sum. This one is a product. And that's the whole point of factoring. We want to take sums for polynomials into products. That's the only point to factoring. I'm going to move on to the next question. Everybody have those notes? Can I slide? Okay. Okay. So this one here, I'm just going to start from the beginning. Put them in pairs. For the first pair, what GCF could come out of that? A 2 and a x. Divide 2x from both of those. Now what needs to be factored out of the next one? The next pair? What could come out of that? And is it a positive or a negative 3 that you're factoring out? A lot of you just said 3. You want to take out a positive 3, right? So you need to include sign here. When you take out a positive 3, what's left over? They got the 4x minus 1 on both terms. That's a common factor that can be factored out. What's left over? 2x and 3. This is going to take a lot of you a few days of hard work. If you don't commit to that hard work, a lot of you will crash and burn on this test. Some of you already crashed and burned on the roots and powers test. And if you continue to crash and burn, then you're probably going to have to repeat 10C. And that's not a good thing. We're into the middle of 10C where historically students can have problems. So you're going to have to take a hard look in the mirror and decide if repeating a course is something you want to do. It's not something you want to do. So you're going to have to really work hard. If you haven't really been taking your math home this semester, now's the time where you have to. It's a must. The measurement and trig you can get by just doing stuff in class. This kind of stuff, you got to be practicing at home as well as in class. Let's jump to the next one. Grab the pair. What's coming out of the first pair? What is it? And how many A's? Open up a bracket for 2 spots. Divide 4A from both those guys. 2A. When they're identical, it's always left with a 1. Now, in elementary school, you guys spent probably many years on patterns. Look at the pattern in the sign. This term is positive. This term is negative. And then it reverses. This term is negative. This term is... That's not good. So what I'll do here is I'll actually factor out a negative GCF. In all those previous examples, we factored out positives. Here we're going to factor out a negative, which will reverse that pattern, so that the pattern goes plus, minus, plus, minus. That's what you need, so that this 2a minus 1 is identical here. So for those two 10a and 5, what's the GCF? 5, and I'm going to purposefully take out a negative 5. Now when you divide by a negative, signs will switch. So you're left with 2a minus 1. I'll use my pointer. Negative 10a divided by negative 5, 2a. Positive 5 divided by negative 5. That ensured that these two guys are identical. That's tough for a lot of students. It will take practice to get better to spot that. These are the two factors in the final statement. That's the final answer. The 2a minus 1 is a factor. The 4a minus 5 is a factor. Okay. If you had a different color pen, switch to it. We're going to go back. We're going to go back to the first question we did in this bottom part. I'm going to show you this whole class. We've been doing this. Now I'm going to show you the expanding. You guys know this one, right? The A goes in, you get AB. The A goes in, you get AC. You know that one. But what about when it's not a monomial binomial? What if it's like this? I think the sub tried to show you this yesterday. Okay. Do you see how the A goes on to both of them? That happens as well. The A goes on to both of them. But you also have to do the B. The B goes on to both of them. What's A times C? What's A times D? What's B times C? What's B times D? How many terms? Look at these questions. How many terms? That's why it's 4 terms, because when you multiply these suckers, you get 4. Let's do it together. We're going to undo what we just did. X times X. X times 6. 3 times X. 3 times 6. These guys are like terms. Do you agree? This is called FOIL. It has an acronym. Yeah. First, outer, inner, last. This is the first, this is the outer. This is the inner, this is the last. Okay, let's do this one here. 4x times 2x. 8x squared. 4x times 3. That's the first and the outer. Now let's do the inner and the last. And then you collect like terms in the middle. You guys do the last one. You guys do the last one. You guys try this one. This one's on you. Oh yeah, so like the order doesn't matter, right? 3 times 5 is 5 times 3? Yes. Yeah, but yeah, do it what you're comfortable with. I did that on purpose to mess with people. Four a times 2a. 4a times negative 1. Negative 5 times 2a. Negative times a negative. And collect like terms in the middle.